Yeah, good morning all. Now I am going to explain about biasing of a PN junction diode. Okay, now see here. First of all, here it is a symbol of a PN junction diode. Okay, PN junction diode is having two terminals. First one is anode. Okay, the P type material, P terminal is nothing but anode. Okay, here N terminal is nothing but cathode. Okay, that means the PN junction diode is having two terminals, one as anode, another one as cathode. Okay, now see here, biasing of a PN junction diode. Biasing is nothing but applying a external DC voltage to the PN junction diode is known as biasing. Okay, when DC voltage is given to the PN junction diode is nothing but a biasing. Okay, based upon the supply polarities. Okay, this biasing is classified into two types. Okay, first one is forward bias, second one is reverse bias. Okay, first we will discuss about forward bias. Okay, see here, this is a PN junction diode, right? Here I am considering only majority charge carriers. In P type, holes are majority charge carriers. These are the holes. Similarly, N type, electrons are the majority charge carriers, right? Okay, negative ions and positive ions, that is nothing but a barrier potential, right? Okay, now forward bias is nothing but when P type material is connected to positive terminal of the battery and N type material is connected to negative terminal of the battery, or anode is connected to positive terminal of the battery, anode A, cathode K, and cathode K is connected to negative terminal of the battery, then the diode is said to be in forward bias. Okay, now see here, when P type material is connected to positive terminal of the battery, okay, these holes are having positive charge, right? This positive charge is again connected to positive, right? Two similar charges will be repel each other, hence there is a force acting on the junction, right? Similarly, when negative terminal is connected to N type material, right, already we know that these electrons are having negative charge is connected to negative terminal, right? Again two similar charges will be repel each other. Okay, that means if diode is in forward bias, okay, then the force acting on the junction increases. Okay, when force acting on the junction increases means this is the depletion region, right? The width of the depletion region is reduces. That means if we increase the supply voltage, the width of the depletion region is reduces. Why? Because force acting on the junction increases means width also reduces, right? At a certain potential, okay, total barrier potential will be eliminated, hence recombination takes place. Okay, when recombination takes place, it will constitute a current. Okay, that is about forward biasing of a PN junction diode. Okay, next one is reverse bias. Okay, reverse bias is nothing but when negative terminal is connected to P type material and positive terminal is connected to N type material, okay, then the diode is in reverse bias. Okay, now see here, when diode is in reverse bias, already we know that these holes are having positive charge, right, and positive charge and negative charge, right? Opposite charges will be attract each other, then there is a force acting away from the junction. Similarly, positive charge and electrons are having negative charge, right? That means again there is a force acting away from the junction, right? That means these holes will move towards negative terminal. Similarly, this electron will move towards positive terminal, right? When this hole will move towards negative terminal, which will create additional negative ions near the junction. Similarly, when this electron will tries to move from positive terminal, again here positive ions will be created. Creation of positive ions increases, right? That means if we increase this reverse bias voltage, okay, positive ions, negative ions creation is also increases, then the width of the depletion layer will be increases. If we increase the reverse bias voltage, the width of the depletion layer will be increases. Okay, that means there is no recombination takes place. That means there is no current. That means it will not constitute any current in reverse bias. Why? Because the width will be increases. Okay, there is no possibility to eliminate that depletion region width, right? Hence diode, it will allow current only in one direction. That means in forward bias only it will allow current. In reverse bias it will not allow current. But we know that p-type material, electrons are the minority charge carriers, right? Similarly n-type material, holes are the minority charge carriers, right? Okay, now see here, plus and plus, right? Again some force, again minus and minus, there is some force. That means due to minority charge carriers, okay, small amount of current is flowing through the diode. Okay, due to minority charge carriers, small amount of current is flowing through the diode. Okay, this current is known as reverse saturation current. Okay, that is about biasing of a PN junction diode. Okay, thank you all.